welcome to the first in my Fusion 360 tutorial series. We're going to be going from a blank slate in Fusion 360 all the way to some finished designs. When I do tutorials, I don't really like doing abstract or arbitrary projects. I'd like to do something that when we're done you can actually use. So I put up a poll in the Monoprice Select Mini Facebook group a while back, asking what people wanted to use as a platform between Onshape, which is another cloud-based design suite, and Fusion 360, and it was actually pretty close, but Fusion 360 won out, and actually since then, Onshape has pushed out an update to their terms of service, which actually makes it probably less of an option than it used to be, and makes Fusion 360 probably even better of an option. So what are we going to do? Well, what I think we're going to do is we're going to design another cooling fan shroud, because there's not enough of them. I slightly kid. The goal is to design a shroud that is very compact, very lightweight, but provides better cooling than anything else you can currently get, including my own fan shroud design that I made for the stock hot end. We're going to be using a blower fan for this, and I'm going to quick pull up the fan that we'll be working off of. So this is a really compact design. It's one of the smaller ones you can get that is inexpensive and widely available. There'll be a link in the description down below to this fan if you want to pick one up. What I like about this is that it barely weighs any more than a 40mm fan. It has a lot more ability to develop pressure, which is important for nozzle designs where you have restriction and the fan can't just blow in an unrestricted manner. Also, because it's a cage fan, we can mount it vertically, which means we're not going to have a lot of mass hanging off of our hot end, which should keep the hot end fairly stable and not add a lot of noise to our prints or ringing to our prints. I'm going to be using my caliper, and I've got one of these fans in my hand right now. I'll be using that as I work through the design. I'm just doing this off the cuff. I haven't worked out any design prior to this. You're going to be kind of seeing the design process exactly the way I would approach something if I were starting from scratch. If you don't have a caliper, I would recommend picking one up. You can pick up even a $20 cheap one for this kind of work. It doesn't have to be an expensive machinist caliper. I'll put a link to what I'm using down in the description as well, in case you want to pick one up. And it's helpful whenever you're designing things that need to fit or have specific dimensions that need to be accurate or need to match up. And it's a good tool to have if you want to get into functional design and 3D modeling. Okay, let's get started. So Fusion 360, just briefly, I'm not going to go into the whole how to download Fusion 360 or how to install it. There's plenty of instructions for that online. All you need to do is go to their website and you'll find the links you need. They have a pretty wide breadth of licenses that you can qualify for, anywhere from a student or educator to a free trial to actually free use as a startup or a hobbyist as well. So pretty much anybody out there is going to be able to find a license that works for them and provides 100% full functionality. You're not going to have any features that are disabled or withheld. So props to Autodesk for coming up with a model that hopefully is making them money, but is also allowing people to get into design without having to shell out a ton of money to do so. So the building block of Fusion 360 is going to be our sketch. And this is where we're going to start on a two-dimensional plane. We're going to draw out or sketch out some profile, and then we're going to start bringing things into the third dimension using the create category. So we're going to start with sketch. I'm not going to try to explain every single menu or submenu ahead of time. We're just going to take them as we hit them. So right off the bat, I'm going to start with a new sketch, and it's asking me which of the three planes, X, Y, or Z, I want to begin, and I'm actually going to begin in the front plane here. Okay, so to start off here, I'm going to be just drawing a rectangle, and we can do it with a 2-point where we mark opposing corners, 3-point or center, and I'm going to do a center, put it right on the origin here. We're going to open it up. I did a couple measurements on my Monoprice Select Mini before I began the tutorial, and I think that I want roughly a 60 millimeter long rectangle, and you'll understand why I'm doing that in a minute here. I'm now going to go down to sketch dimension, grab this side, and type in 60, pull that in, and then the fan is approximately 20 by 25 for an opening. So I don't want my shroud to be too much smaller than that, because even though it's a blower fan and it's able to produce more pressure than a standard rectangular fan, the more open we can leave our duct, the more air we're actually going to get for cooling our part, which is the whole goal here. So I'm going to set this other dimension, for the moment anyways, at about, let's do 22. I'm just throwing that out there. We'll see how long that stays around for, but let's throw that out there. Okay, so there's a rectangle, and you're probably going, wow, this is not a very good fan duct. What are you doing? And you will find out shortly. So I'm going to stop sketch. I'm going to basically end the sketch and finalize it. Next, I am going to create an extrude. And it's going to ask me to select a profile. And I'm just going to select the sketch that I just created. And there's a couple ways of doing this. You can type in a specific dimension. You can grab this arrow and drag out your extrude. Again, kind of going off of my gut here, I think we're going to want a roughly 30 millimeter depth here. And we'll be able to go back and fine tune these if we need to as we go along. Now, I am going to create a new sketch, and I'm going to actually start that sketch on this face. And this is going to be the profile of our cooling shroud. Now, a couple things. We're going to go up to sketch. We are going to grab an arc. We're going to grab a 3-point arc, and we're going to begin it there, and we're going to end it roughly there. And when we get the tangent marker here, we're going to confirm. Next up, we're going to go back to sketch. We're going to grab another rectangle, and we're going to make a 4 millimeter line, and we're going to go in about 25 millimeters. And actually, we're going to tweak one dimension on that. We're going to make this 3.5. There's a method to my madness. We're going to go back to arc. We're going to go back to 3-point arc. We're going to grab here. Now, I want this endpoint to be roughly the width of our blower fan opening, which is right about 20 millimeters. So I'm going to select here. I am going to place the arc. Then I'm going to go back to dimension. I'm going to grab the arc endpoint. I'm going to grab the side of my shape here, and I'm going to push this out to 20 millimeters. Okay. Next up, I'm going to grab just a line. I'm going to connect this arc to this rectangle. And what I'm doing now is I'm just creating a closed a closed sketch so that we can extrude this. Okay, so I'm going to go to create, I'm going to go to extrude, and I'm going to select the voids, and I'm going to select one side, extent, all, and instead of operation of new body, I'm going to do cut. So I'm going to remove material, and then I'm going to flip the direction we're going, and we can see here that with those constraints, it's going to remove all of that material. I'm going to select OK. And now, just maybe, you'll be starting to see our fan shroud take shape. Now, if you can imagine, because I haven't explained where this is going to mount or how this is going to mount, but if you have a monoprice select mini, if you can imagine your hot end coming straight down here, and if you can imagine a semicircle cut out of this so the air can blow in from multiple angles. And if you can imagine that this is hollow and there's a fan mounted right on this top section here, you can kind of begin to put together the rough goal that I have. And mind you, I'm working this out as I design it, so we're probably going to be tweaking this quite a bit. And you're designing this along with me, hopefully. And so you're free to take this design in whatever direction you want to once you begin it as well. So it'll be interesting to see what people come up with out of this tutorial. Okay, so next up, we are going to create another sketch. And, oops, we're going to look at the bottom of this, and we're going to make the sketch here. And we're going to grab a 3-point arc, and we're going to put it roughly in the middle, and we're going to put it roughly there. There we go. Now, I don't want this space right here. I want this to be tangent to this line. So I'm going to grab those two, and then I'm going to go oops, that is not what I wanted. I'm going to go tangent. There we go. Oh. There we go. Tangent. Alright, let's close that off using a line. There we go. And I'm going to stop sketch. I'm going to extrude. I'm going to select that sketch we just made. I'm going to select operation, cut. I'm going to extent all. I'm going to flip the direction. I'm going to click OK. And we are headed in the right direction. Now, we need to know if this is going to blow right up next to our nozzle, but without blowing all over our heater block and unnecessarily wasting energy. What kind of radius do we need to cut out of here? And if you go and you look at your hot end, if you're using the stock hot end, you're looking at needing a radius of roughly an inch, or roughly 25 millimeters. So let's start with that idea. Let's do another sketch. Do it from the top here. And let's actually just make a circle from a center diameter. I'm going to throw it in kind of an arbitrary point here. And we want it to be about an inch. And we can grab this and we can actually just move it around. So you can kind of imagine as we move this around where the air is going to be blowing and how that's going to sort of be encompassing the nozzle. The goal being that when we're done with this, we'll have it directing air not at the nozzle, but just right around it and down, so that as the plastic is being extruded, we're blowing on it when it's appropriate, and creating much crisper parts with clean overhangs and detailed features that sometimes get muddied if you're running with improper or no cooling and the plastic is staying molten for too long. So I'm going to go out on a limb and I'm just going to position it about here. I'm going to position it about there, and then I'm going to extrude it. And again, we're going to do a cut, and we're going to do all, and we're going to flip the direction, and we're going to accept that. And now you can kind of see roughly where our nozzle is going to be located. Now, before we get too much further, we kind of have to think about the direction that we want our air to blow and how we're going to accomplish that. If we were to simply hollow this piece out, which we could do right now with a single push of a button, we'd have air blowing straight out. That would probably be okay, but it probably wouldn't be ideal. So let's take a look at creating shaped airflow a little bit. It's not going to be perfect, and to be honest with you, with the levels of airflow that we're going to be generating with this fan, you're still going to get some air hitting the nozzle, hitting the block a little bit, because you're blowing down at a surface, which is then going to generate airflow and turbulence around the heater block. But in the name of science or something like that, let's try to be a little bit intentional about this, and here's how we're going to do it. So we're going to create a new sketch, and we're going to start it on this plane. And we're just going to create a roughly 45-degree triangle, like so. And I want to leave um, 0.8 millimeters of material there. And now I am going to do a create and sweep. And here's how we're going to do it. We're going to select this face. That's what we want to sweep. And then for the profile, we're going to select for the path rather, we're going to select this radius. And as you can imagine, we're going to be cutting. And we want the orientation to stay perpendicular to the path. And that's about all we need. So we're going to select OK. And now you can kind of see that we're starting to make a little bit of sense here with the direction that hopefully we'll be able to encourage air to flow. Now, before we do anything else, let's go up to Create and, or rather Modify, and we're going to choose the shell option. And we are going to shell from our nozzle face. And we want our thickness to be, let's do 1 millimeter for now. Let's take a look at that. So you can see it's now hollowed out our entire shape, and it's left 1 millimeter of thickness all the way around. So that's pretty good. That's pretty good. And I think that for something like this, we could probably even knock it down to 0.8 millimeters, and anybody printing with a 0.4 millimeter nozzle will then be able to do a 2-shell slice, and it would work out pretty good. But we'll leave it at 1 millimeter because that means that if you're using a 0.5 millimeter nozzle, you can still get exactly 2 shells. And if you're printing with a 0.4, you'll get 2 shells with a little bit of gap between them, where you can do 100% fill or some percentage of infill, and it should produce a pretty functional print. Okay, so this is getting there. We've still got quite a few things to cover, and I'm actually going to back up that last option, and I'm going to show you something. Down here is our design history, so you can go back and you can look at every single item that we've done from every sketch, every operation, and I'm just going to drag it back one, and boom, our shell there disappears. One of the things you want to do before you generate shells is that if you have any type of radiusing, fillets, anything like that, you want to do that before you create the shell, because then when you create the shell, the internal wall thickness, or the wall thickness everywhere, is going to remain constant. If you do a shell and then do radiusing, it will create thin sections in your part that will not print well and will make a weak object. So let's go up to Modify. We'll grab Fillet, and let's smooth this up a little bit, just to make it look pretty. So let's grab a couple edges, and let's start with a 2mm fillet. Everybody just went ooh, ooh ah. So I accidentally accepted that fillet. We can wrong click on our fillet, which is the most recent item in our history, and we can click Edit Feature, and we can keep adding edges. Maybe, if it'll let me. There we go. For some reason, it's giving me a hard time tonight. Alright, let's take that from the top. Alright, so we'll select a few edges here. Alright, and then we can also use this arrow if you just want to create the radius sort of by feel. So there's a 2.5. It's pretty good. Let's do something real quick before we finalize that. Okay, let's select almost all of the edges, and then let's start to add this radius here. And you'll see that if I ask for too much radius, the radiuses will start to intersect, which will create an invalid operation, and we'll get that warning down there. So we just back it off, and it corrects itself. So I think a 1.5mm fillet is what we're going to go for, and we'll select that. That looks nice. So now let's go ahead and redo that shell. Again, we'll select this face, tell it we want a 1mm shell. Oh, man, what is it unhappy with? Doesn't like something. Let's see here. Okay, so we've got some collision, and I think I know what it is. Let's go back to our previous fillet. We're going to edit it. Let's back it off to a 1mm only. Now, when we ask for our 1mm shell, we don't have any conflicting geometry. We're able to shell that out nice and easy. Still have a nice radius on the entire part. I think it was kind of getting twisted up in this area right here. And the 1.5mm fillet that we did for the sides of the part was preventing us from generating that 1mm shell that we needed to generate. So we are past that now. Now, obviously we created the shell from one face, and the entire inside is hollow, but this is still 1mm thick, so we'll have to deal with that shortly. Before we do that, though, let's create a flange that will fit inside the face of the blower outlet. Now, from the fan that I have here, I can measure, and our inside dimensions are about 17.25mm by about 26.75mm. However, there is a angle on one side of the opening that we'll have to account for. But first things first, let's generate those dimensions. Okay. So we're going to start off with a center rectangle, and we'll start there. We will add our dimensions. So we're looking at about 26 3/4. And we're looking at about 16 1/4. And we want this distance to be 2. Just verify that's 1.75. Let's make this symmetrical if we can. There we go. Okay. So this is the inner dimensions. Now obviously we need some thickness to this if we're going to create a flange. So we'll just generate another rectangle stemming from this center point. We'll open it up here, and then we'll give it some wall thickness. So we want this to be, let's do 1.2 and 1.2. And it thinks it's overdimensioned for some. Oh, I know why it's overdimensioned. We can just back that up. What is overconstrained here? It should not be overconstrained. Alright. What is that? Yeah, that doesn't like that. Okay. Something is causing us a problem here. What constraint is it? Let's remove that and see what we get. Oh, okay. I must have accidentally added a constraint in there that I did not realize I was doing. Let's try that again. Center rectangle from this center point. Oh, that's what the issue is. I allowed my cursor to snap to the same proportions as the existing rectangle. And when I did that, it would no longer let me alter the ratio of the length to the width. We don't want that. So we don't want to have it snap to that. The only thing we want it to snap to is the center of the pre-existing rectangle. So let's do that. Go back to sketch and dimension. 1.2 millimeters. That worked out kind of nice. And 1.2 millimeters. There we go. Now we've got a constant thickness flange here. We're just going to extrude this up. We'll select that, and let's just go up 2 millimeters. Okay, perfect. And let's finish hollowing this out. So we'll go with a modify. We'll go with a, oh, I'm sorry, not a modify. We'll go with a create extrude. We'll just select this surface that's sort of created for us automatically. Operation cut, and then we'll go down 1 millimeter, which is the thickness of our shell. That completely removes that surface. We'll select OK, and we now have something that's actually beginning to look like a fan shroud. Now, there's a lot of directions you could go with this. For example, if you wanted this to be more of a 360-degree shroud, before we had done our radiusing and our shell, we could have added a feature on this side that created more of a 270-degree circle and transitioned into the side of this to try to blow air not just from the front and side, but from the front and two sides. One of the constraints with the Monoprice Select Mini is that the hot end carriage homes basically up against the side of the machine on one side, so we can't have any portion of the cooling shroud wrap around that side of the hot end and run into the side of the printer when it homes. So we have to come in from the right side of the hot end as we're facing it, and our cooling nozzle has to stay on the front, the right side, and the back. It can't go any further over. So that's one thing to keep in mind. That isn't a limitation on other printers that we have to work around. But to be honest with you, even if you used it exactly like this and you didn't add any additional cooling nozzle orientation to it, with this cooling fan, which is going to produce a lot more air than most 40mm fans, and certainly more than the 30mm fan on the stock unit that is used for both cooling the hot end and cooling the part, you're immediately going to have much improved cooling. Okay, I think I'm going to call it this for the first tutorial. I don't want this to get too long, so we're gonna stop here, and we'll pick up next time with adding a bracket so that the fan can sit on this flange, and then a screw can hold it in place. And then we'll be looking at how are we actually going to mount this to the hot end. One of the ideas I initially had was that I would take my ABS hot end cooling fan shroud and I would morph it into this part cooling fan shroud, so that you would have the ability to disable the part cooling fan and print just with the ABS hot end cooling fan, and then you could enable the part cooling fan if you're printing with PLA or something like that, where you need that extra cooling for good prints. So that might be an option. It's possible we will make it mount as kind of a standalone shroud that doesn't rely on anything else. We'll see. And obviously, if you're following along with this tutorial yourself, you can take this design in any direction that you want. Well, thanks for hanging in there with me, and I hope this is getting people interested in design, getting your feet wet, and hopefully by the time we're done with this, you'll have enough knowledge of the basic workflow of Fusion 360 to start from scratch with some of your own ideas, start creating. Downloading things from Thingiverse or other part sites is great, and you got to start somewhere. But once you start creating your own designs, it opens up an entire new level of functionality for your 3D printer. Alright guys, we'll catch you next time.